Section 9.3 is even more about parabolas and their applications. Friendly note that from this section, you will have to know how to complete a square. That's a method we learned back in section 8.1. If you do not remember how to complete the square, stop now, go watch the video for section 8.1, and come back. So if I have a quadratic function, typically we've seen them in the form f of x equals ax squared plus bx plus c, where a doesn't equal 0. Well, last class, I had you graphing things that looked like parabolas, so they were definitely quadratics, that were in this form. And so I'm going to show you how these two relate. So our vertex I had mentioned in the last video was hk. Well, hk can be found by taking negative b over 2a, so that'd be our x value, right? And then I can find my y value, k, by taking f of negative b over 2a. So plugging this back into our original function. The line of symmetry is x equals negative b over 2a. A parabola opens up if a is greater than 0. And if it opens up, it has a minimum point, so a lowest point, and that makes sense. A parabola is concave down, or it opens downward, if a is less than 0, so negative, and then our vertex is our maximum point, so the largest value. So let's suppose the quadratic function f of x equals ax squared plus bx plus c, and if f is written as f of x equals a times x minus h squared plus k. What I want us to do is I want to find our vertex. So I know that my k is f of h. There's a formula for it, but I don't care for it. We're going to ignore that. So I have to label my A, B, C. So here A is 2, B is 8, C is 5. I'm going to go ahead and find my vertex. We are not putting it in vertex form just yet. I want us to get practice finding the vertex. So H is negative B over 2A. So I have negative 8 over 2 times 2. That's negative 8 over 4, which is negative 2. Then, so I know my x value, my vertex is negative 2. Then I'm going to find k by taking f of h. K is f of h, which is f of negative 2, which would be substituted into my original function. So I have 2 times negative 2 squared plus 8 times negative 2 plus 5. So that gives me 2 times 4 minus 16 plus 5. So I get 8 minus 16 plus 5. That 8 minus 16 is a negative 8 plus 5 is a negative 3. So my vertex is when x is negative 2, y is negative 3. Let's try this again. I want to go ahead and find the vertex of f of x equals negative x squared minus 9. We're going to use this formula even though you can probably tell, okay, this is a parabola that's been flipped over the x-axis because it's got a negative, and it's been shifted down 9. So its vertex would only be altered in its y value. But let's test my hypothesis. So I have x, and I'm going to label my ABCs. So A is negative 1, B is 0 because there's no x term, and C is negative 9. So if I have H equals negative B over 2A, well, that's 0 over 2, that's negative 0 over 2 times negative 1. Well, anything divided by 0 is just going to be 0, so we got that. Cool. And then if I plug in 0 into our function to get our k, I'm going to take f of 0, which is negative 0 squared minus 9, which is going to be a negative 9, like I predicted. So try and visualize when you can what some of these parabolas look like. So how do we go about graphing a quadratic function? So the first thing we want to do is determine whether the graph opens up or down, find the vertex, find any x-intercepts, and then find, if there are no x-intercepts, you find the values f of h plus 1 and f of x minus 1 as needed, okay? Because you need 3 points to graph a quadratic function. So let's determine this graph of f of x is x squared minus x minus 6. Well, this graph definitely opens up. Our a is constant, our a is 1. So then I need to find my vertex. A is 1, B is negative 1, C is negative 6. H equals negative B over 2A. You will need to memorize that. So I have negative 1 over 2 times 1. So I get 1 over 2, which is 1/2. Then I'm going to plug that in to my original function. Yes, I am. So f of h is going to be my k. So I'm going to get 1/2 squared minus 1/2 minus 6 by substituting this in for x. So I get 1/4 minus 1/2 minus 6. Let's write all of these as fractions over 4. So I have 1/4 minus 2/4 minus 24/4. So I get a negative 25/4, which is just a little bit more than negative 6. So I have when x is 1/2, y is negative 25/4, which is a little bit more than negative 6, so it's right here. Then I'm going to find the intercepts by setting our entire function equal to 0. Well, okay, I can find, this is how I find the y-intercepts, right? If you plug in for 0, that's how you find the y-intercept. So if I have f of 0, that is going to be 0 squared minus 0 minus 6, so that's negative 6. Now I now know when x is 0, y is negative 6. Okay, we do have symmetry, so if x is 1, 0 should also be negative 6. But we could also find our x-intercepts. To find our x-intercepts, you let y equal 0. So I have 0 is x squared minus x minus 6. And what do? We factor. We know how to factor this. What are the factors of AC that add up to B? Well, the factors of negative 6 that add up to negative 1 are negative 3 and 2. So I have x minus 3, x plus 2. That means I have x minus 3 is 0, so x is 3. And x plus 2 is 0, so x is negative 2. So when y is 0, we found a couple more points, x is 3 and x is negative 2. 3, negative 2. So now I found way more than 3 points and was able to graph my function. Otherwise, you want to find 2 points equidistant from your vertex because they are going to have the same y value. This function has a domain from negative infinity to positive infinity, a range from negative 25/4 to infinity, and an axis of x equals 1/2.